Okay, so you guys did systems of inequalities last week. So compound inequalities are expressions with two or more inequalities joined together with either and or or. So two inequalities like x is greater than negative 3 and the inequality x is less than 2 can be joined together with the word and. Another example would be x is less than negative 6 or x is greater than or equal to 1. When two inequalities are joined with and, they are often written simply as a double inequality. So basically, you can write them as two inequalities within one. You would keep your negative 3 and keep your negative 2. X would be in the middle. So it reads from the least value to the greatest value. So x is greater than or equal to negative 3, but less than 2, or and less than 2. For and inequalities, the solution is an intersection, or where the graphs of these inequalities would overlap. To find the intersection, determine where the two graphs of the sentence overlap. On a number line, you would shade the middle. So the intersection is the middle of the 2 points. So you would have 2 points, and the shading would go in between. The solution of an or inequality is the union of each individual inequality in the sentence. So in an or inequality, solve the two inequalities separately and combine the solutions together. So for an or, you will have the outsides, and for an and, you will have the middle. So let's graph these inequalities. X is greater than negative 2, but less than 3. So I just plot some numbers on here. Let's just do 0, 1, 2, 3, 4. So x is greater than negative 2. So at negative 2, we need an open circle. And less than 3, we also need an open circle. Since it's an and, we need to shade in between. So everything in between, but not including negative 2 and positive 3 is going to be a solution for both of these inequalities. Now what about x is less than negative 2 or greater than 3? So now we have to recognize that it's an or. Anytime it's an or, it should shade outwards, but let's check. So same numbers. Still both open circles, because it's not or equals to, but now it's less than negative 2 and greater than 3. So they do go outwards. So there's another way that we can write the same thing. When we read x is less than negative 2 or x is less than or equal to negative 3, we can write it as an inequality, but we can also write it using interval notation. So we're just going to call a and b some numbers just for our example. So say x is greater than or equal to a. So a is some number, and b is some number, and it's less than b. Your interval notation is going to be from a to b. It's an and inequality, so it would be in between those numbers, a and b. But because a has a less than or equal to, if it has an or equal to, we can't use parentheses. So interval notation uses brackets and parentheses. So when we see that it's an or equal to, we need to say, okay, it's including whatever that value is for a, starting there, going all the way to b, but because it doesn't have an equal to, it's going to use a parentheses. So you guys know that if it's or equal to, if it has that little line underneath of it, then you need a closed dot. So on the number line, again, we don't know what A and B are, but they are some number value. On your number line, you would have A, B, you would have a closed dot at A, and it would go to B, but not include it. And that's it. So what this means, guys, is that if you guys see the less than or equal to or greater than or equal to, then we have to use brackets. But if it's just less than or greater than with no equals to, then we have to use parentheses. So let's try one here. I'm going to do the first two, and then you guys will have to try the second two. So it says, express the following as an inequality, an interval, and a graph. So x is greater than -3. So this looks like it's only one single inequality. It has an x, and x has to be greater than -3. So the interval, if it's not equal to, we want everything from -3 and greater. So we're going to start at -3, and everything greater would be every decimal, every fraction, every whole number, every number you could possibly ever think of that's going to be greater than -3. So we're going to be going all the way to positive infinity. It's never actually going to stop. We want to include every number out there bigger than -3. Now, how do we graph this? Well, on your number line, and you guys don't need a bunch of numbers, you just need a few. So 0 is going to be open, and it's everything greater. So it's going to be going to the right. So that would be x is greater than -3 in inequality, interval, and graph notation. Okay, so now we have an example of an and inequality and an or inequality. So the first one says x is greater than or equal to -1 and less than 4. So the and means it's going to be written as one inequality. It's two written within one. So first let's write our two numbers that we have. We have -1, which is our lowest value, and +4. X goes in the middle. So now it says x is less than 4, but greater than or equal to -1. So, just a hint, guys, or a trick, when you guys are making an and inequality, your inequality should always be going to the left. As long as your lower value is here and your higher value is here, both of your inequalities will always be going or pointing to the left-hand side. So, you guys probably can read x is less than 4. That makes sense. But when it says x is greater than or equal to, you guys are probably thinking this. But then that's not right because your inequalities are pointing towards each other. So, since x is now on the right-hand side of your number, it's actually sort of backwards. So to write greater than or equal to, the greater part, the open part, has to be towards your x. So that's how you would write x is greater than or equal to -1, but less than 4. But now how do we write this as an interval? Well, same thing. You start with your two numbers. So we have -1, and it's going to +4. But do we need brackets or parentheses that are -1 and 4? Well, since the -1 is being included, it's less than negative, or it's -1 or greater, we need a bracket. And 4 is going to be a parentheses because there's no equal to line there. So your interval will be -1 to +4. -1 gets a bracket because it's included. 4 gets a parentheses because it is not included in your solutions. It's everything up to +4. And then your graph. So from -1 to +4, close circle because we're including it at -1. Open circle at +4. It's an and, so we go in the middle. We include everything in the middle where they would overlap. So now you guys go ahead and try letter D. It's going to be very similar to C. And I'm going to actually scoot down here and do number 3 with you guys. So everything I'm skipping, you guys will have to make sure that you get that you try in class or get done for homework. That's your practice. So for number 3, it says write as an inequality and an interval notation. So as soon as I see these two separate pieces, guys, I need to know that that's going to, or recognize that that's going to be an or inequality. Or goes separate directions. It's two pieces of on the graph. So I have my number 7 and I have 11. It looks to me that from 7, it's going to the left, so it's including everything less than. And that open circle makes me think, okay, if it's open, then it's not less than or equal to, it's just less than. So my first inequality is going to be x is less than 7. And then my second inequality, we're going to be starting at 11, but it's closed and going to the right. So it's greater than, but it's greater than or equal to because of that closed dot. So x is less than 7, or x is going to be greater than or equal to 11. So that's my inequality notation. You guys also have to write it as an interval. So this is where we see the U, which means union. So anytime you have an or inequality, if you're written to write it as an interval notation, you're going to have to use this U. So everything less than 7, we're starting at 7, going all the way to the left, including everything less than, everything smaller than any number, fraction, decimal. So everything all the way to -infinity to +7. And 7 is going to get a parentheses, guys, because it's an open circle. It's not closed. So we're going to stop at 7, and then we're skipping over all of these values that aren't included in the solution. And where are we starting again? We're starting at 11. And then 11 has a closed circle because 11 is included in the solution. So we're going to start back at 11, include it, and then everything possible that would be greater. Your infinities, guys, always get parentheses because you can never actually reach infinity, so it can never be included in your solution. It's just an expression saying we're including everything possible that we know of greater than or less than these values. So your infinities, positive and negative, will always have parentheses. And if it's an or, we're going to need that U or that union. Okay, so let's actually get into solving one of these. I'll do 2 of them with you, and then you guys will have to try the rest. So the first one we'll solve will be an and inequality. because it's 2 in 1. You have 2 inequality signs. So, solving an and compound inequality is like solving 2 inequalities in 1, and you're trying to isolate or get that x by itself in the middle part of your inequality. So when we're doing this, sometimes it helps people to draw lines, and that's fine if you want to. What you just have to realize that in the normal equation, you have to do something just to the left and the right hand side of the equal sign. Now you have 3 sections that you have to do the same operation, depending on what that operation is you choose. So if we're trying to get rid of, or if we're trying to get this x by itself, what's the first thing you guys would do here? As I'm looking at this, I would choose to get rid of my 5 first. So we need to subtract 5, but be careful. Just like an equation, we need to keep our inequality equal in all 3 portions. So if we are going to subtract -5 to try to isolate that x, then we have to subtract 5 everywhere. So 3 minus 5, and then just bring down your signs. We're left with 2x in the middle, and 15 minus 5. So then the last step is to divide by that number in front of your x, which you guys know is always your last step. So 2 divided by -2 is -1. Bring down your signs. You now just have x. And 10 divided by 2 is 5. So this is what you guys will be able to graph. And just remember, if this 2 would have been negative, if we were dividing all 3 portions by a negative value, then we would have had to switch that inequality sign. But we are not, so they can stay. So now we just need to graph them on here. So let's see, 0, 1, 2, 4, 6, 8, -4, -6. Okay, so it looks like we have an open circle or an open dot because we don't include -1, but we are including +5. So your solution, it's an and, so it goes in between. One open, one closed, one answer is included, one is not. -1 to +5. X is greater than -1, but less than or equal to 5. So it's just like solving 2 equations or 2 inequalities at once. You do it all at one time. Now the second kind of compound inequality to solve is going to be an or inequality, but they're actually easier, guys, because you just solve each one individually. So it's like what you already know how to do. The next page, it wants us to solve and graph 7 minus 2y is less than or equal to 1, and 3y plus 10 is less than 4 minus y. So literally solve each of them separately. So let's just go ahead and solve the first one. So we're trying to isolate the variable. In this case, our variable is y. So I would subtract 7. I'm just going to solve this first one and then worry about my second one. So -2y that you're left with, make sure you don't forget to bring down that negative, is -6, and then divide both sides by -2. And remember, we just divided by a negative, so that inequality now has to be flipped. And -6 divided by -2 is +3. So that's going to be your first inequality that you'll be able to graph. Now let's go over and solve our second one. Here our y's are not on the same side, so we have to get them to the same side. So I see that even though there's nothing in front of it, this is 1y. So I'm going to add 1y. So we have 4y plus 10 is less than. These are now gone, so just 4. So then you guys have to subtract 10 and get 4y is less than -6. Divide both sides by 4. So you guys do end up with a fraction y is less than negative 3/2 reduced. 6/4 would be 3/2. Whoops, I just erased everything. Or you guys could write it as 1/2, whichever you guys prefer, as long as you know how to graph it. And again, -6 is negative, but we weren't dividing by a negative value. The number we were dividing by was positive. 4 was positive. So there's no need to flip our sign for that second inequality. So the last thing you guys have to do is graph it. So let's see, 0, 1, and you guys can always make your number lines whatever you prefer them to be. It depends on how big your solutions are, that sort of thing. So x is greater than or equal to -3, so we need a closed circle at 3 and an open circle at -1.5, which is in between 1 and 2, -1 and 2. And our dot is going to go to the left for -1.5 because it's less than. But x would also be greater than 3. So that would be your solution and your graph for that second example. So go ahead, try those 3 remaining on this page, guys, and then go back and do the ones that I skipped. So there's 2 or 3 on the other page that you need to try as well. Let me know if you get stuck.